Hello, this is Tom, and in this video I'm going to show you how to use the G75 can cycle that is used for OD grooving on a CNC lathe. I'm going to show you the format that is commonly used on a FANUC 0, FANUC 16 and FANUC 18 series CNC lathe controls. So let's see how that's done. Alright, so for this example we're going to be using a 1.5 inch diameter stock that is sticking out about 1 inch in front of the lathe jaws. We're going to be cutting two grooves with 150 thousandths depth and 125 thousandths wide. The tool itself is also 125 thousandths wide, and I'm going to show you how to add pecking to the G75 can cycle. So let's watch up close and see the operation that we're going to be writing code for. You can see it pecks, backs up, breaks the chip, and goes to full depth on each groove. So let's take a look at the code. Alright, so here we're looking at the G75 can cycle, which is a two-line format. But I want to talk about the line right before the G75 can cycle because we are rapiding into position, the X1.6 being the clearance plane about 50 thousandths above the part, and the Z minus 0.225 is the position of the first groove. And it is important that we start in the correct position before going into the G75 can cycle. Alright, the first line of the G75 can cycle has an R value, and that is the retract amount each time we take a peck. Then the second line starts with a G75. The X 1 inch 200 is the diameter at the bottom of the groove, and the Z value is the position of the last groove in this can cycle. The P400 stands for 40 thousandths. Now the machine does not want decimals, so the 40 thousandths, we take the decimal and move it 4 places to the right, and so we come up with P400. Same thing with the Q. We're doing a 200 thousandths step between the two grooves, and again the machine does not want decimals, so we take the 200 thousandths, move the decimal to the right 4 places, and we come up with Q2000. And then of course the F is the feed rate. Alright, so let's take a look at the definition of these values of line 1 and line 2. Alright, so here we're looking at the first line of the G75 can cycle, which starts with a G75, which calls the grooving cycle, and is followed by an R value, which is the retract amount after each peck, and a decimal is allowed in this value. Alright, so let's take a look at the second line. Alright, so here's the second line of the G75 can cycle, which again starts off with a G75, which calls the grooving cycle. And that is followed by an X value, which is the diameter at the bottom of the groove. The Z is the position of the last groove in the can cycle. And P is the depth of cut, or the depth per peck, which is a radial value, and no decimals are allowed. So in our example we used 40 thousandths peck. You move your decimal 4 places to the right to come up with your value. The Q is the step over. There is 200 thousandths distance between the two grooves, so again we take the 200 thousandths, move our decimal 4 places to the right to come up with our Q value. And then of course F is the feed rate used for the can cycle. Alright, let me show you how to add 2 more grooves to this can cycle by changing only one value in the G75 code. Alright, so we're going to be adding 2 grooves to this can cycle, but let's go over the numbers real quick. This 225 is the distance from the face to the far edge of the first groove. Then the 200 thousandths is the distance between each groove, so that is our step over amount, and the 825 is the distance from the face to the far side of the last groove. Then our 1 inch 200 is the diameter at the bottom of the groove, and the 1 inch 500 is the diameter of the part. So with those numbers in mind, let's first watch what the can cycle is going to be doing. You can see it's pecking each groove 200 thousandths apart, starting with the 225 thousandths groove and then ending with the groove positioned at 825 from the edge. Alright, so let's take a look and see what we change about the code. Alright, so here we're looking at the code that was used to machine the two grooves, where we started at Z minus 225 for our first groove and we ended at Z minus 425. So with a 200,000 step over, we only ended up with one step over, which gave us two grooves. So if we change this 425 to 825, then we have more 200,000 step overs, and therefore with the Z minus 225 being the start point and the Z minus 825 being the end point, we're going to end up with 4 grooves. So that's how easy it is to add or subtract grooves. Alright, so that's it for this video. I'm going to leave you with a copy of the complete program down in the description field so that you can see how the G75 can cycle is formatted inside the program. Alright, I hope this was helpful to you. If you have any questions, leave me a comment. Thank you for watching, and I hope to see you in the next video.